So in question 3, we're given that a uniform beam of mass m and length L. It is connected to a wall with a hinge and a string connecting to the end of the beam. And in part A, we need to draw a 3-by diagram for the rectangle, so for the beam, and we need to draw and label the forces clearly. So what we need to consider here are 3 forces basically. Firstly, we have the weight. The beam obviously has a weight. Since we're told it has a uniform mass, it means that we can place the weight in its center of mass. So we can draw the gravitational force pointing straight down through the middle, just like this. We will also have a tension force that is acting along the string. That will go somewhat like this. Tension is always acting along the string. So we can draw it simply like this. And we will have a third force by the hinge. And the way we can determine the direction of this force. So firstly, we can label this force the tension force. And so for the hinge, we know that this system is in equilibrium. And if that also means it's in rotational equilibrium, it's not rotating. And therefore, if we would write the torque around any point on or outside of our system, it would have to be 0. Therefore, if we choose, for example, this point over here, which passes through FG and also passes through FT like this, it means that our third force will have to pass through this point as well. So the hinge force will have to pass through here as well. If it would not pass through this point, then what would happen is that if it would be like this, for example, we could calculate the torque around this point. These two forces will have a torque of 0 because they pass through that point. However, this force would not have a torque of 0 because there's some non-zero distance here, and therefore the system would not be in rotational equilibrium. And that is why we have to draw the hinge force as we did over here.